Hello and welcome. This is a short time-lapse video just showing how to assemble the blue API Budgie or the yellow air quality Canary. So they're basically identical other than the colors, but I thought I'd just break it down in a time-lapse showing how I assembled it in the hope that it's useful to anyone watching assembling their own. Okay, here we go. So after prepping all of your 3D printed parts and putting in the brass inserts, you can then put in your servo motor and the little PCB that holds the buttons for the top. It's worth just putting in the screen momentarily just to check everything fits nicely before going ahead and putting the sides, the white pieces here, in, because the screws would actually get in the way, so you need to do that before you put the screen in. So go ahead and then put those screws in, and as you can see, just checking everything fits, tightening up. You can put in the PCB even at this stage, as it gives you an idea of just giving good access to all the sort of screw fittings, and checking the end cap fits nicely. I'd say at this stage it's a good place to, because you've got good access, before you put that blue end cap on, to put the servo horn in and screw those essentially calibration screws in lightly, because you'll do the final adjustments later, but set it all up now. And then this calibration disc again, putting the screws in lightly, and you'll dial it in later. And then once you have these, check everything around. I've actually put the power leads in as well. Again, just basic soldering to get the wire connections. Obviously check the central pin on your power supply unit, and then put the screen in, clamp in place with that little white piece. I thought it'd be helpful to do it in a different color rather than blue, but yours should be blue or yellow to match, but it's just showing how it goes into place. It can be a little bit finicky to just get that all so that the screen is nice and flush, and indeed you'll see later on I briefly just switch it on to make sure that it's nicely aligned. So checking everything's alright with the speaker, you'd then put that in place, just tack in with a little bit of hot melt. You can of course super glue these things, but I'm quite a firm believer in that sometimes you want to upgrade or change something, so I quite like doing things that are non-permanent, hence all the brass inserts and screws, rather than lots of super glue and epoxy. So after checking the alignment there, I just sort of filed off a little bit just to make sure it was a better fit. Which is why it's going backwards and forwards and backwards and forwards. And then I was happy with that. And you can see a tip I'm using continually is using a little bit of blue tack to hold the screws on, as my screwdriver, my hex head, is not actually magnetized, and indeed the screws are stainless, so it's pretty hard to magnetize them anyway usually. So after doing that, this is just plugging in the cables in their appropriate positions. Do check the circuit schematic if you're in any way unsure, because obviously you don't want to blow anything up. Truth be told, I did actually miswire the screen one time, and it actually survived, but not that I'd recommend you should do that. But these things usually are pretty forgiving. And so here we go, putting in the last touches of the wiring and the switch and the barrel jack. And you might notice I actually screwed it in place. That's just so I can hold it temporarily in place, but of course we'll take that screw out again and put the backing on again later. So there we have it. I'm just basically uploading the stuff onto the Arduino Nano 33 IoT board, and indeed do remember to do the same with the audio files for the Adafruit soundboard as well, before you screw all the back covers on. So again, that's just me switching things on, checking the alignment of the screen as mentioned. Again, the beauty of using a little bit of hot melt there means I can sort of tweak it around so that it's nicely square and level. And then, as mentioned, putting all the rest of the screws in. And so here we have, just checking everything is all aligned properly. And there you can see I'm just test fitting the screen because it makes sense. If you actually do any of the sort of like filing, you find that it just sticks to the PETG, which is the clear film that I was using. and is a bit of a pain. So here we are, just checking the fit of everything. And then of course this next stage, you can see I've fitted the shiny PETG inserts into these. And this just means, very much that if you were, as hopefully this model will be, at a sort of trade show or any sort of exhibits, it means that kids and adults alike can see how the thing basically works on the inside. And that I quite like the fact that we're using a mixture of homemade prototyping boards, but also stuff that's off the shelf for simplicity and also cost, as well as this is certainly something that you can, anyone who's reasonably familiar with a soldering iron and being able to do a little bit of through-hole soldering shouldn't be too intimidated by, as long as they can follow a circuit diagram. So there is no fancy sort of reflowing or solder paste needed. This is all basic soldering techniques, which is certainly the level I'm at, and my workshop doesn't have any of those fancy tools or equipment. So there we are. Of course, it would be nice later on if we ever actually do get enough interested in this project, then as with Radio Globe, which you're welcome to check out as well, we were actually able to sort of spin up some boards, which mean that you don't have to do all the circuit soldering yourself. But I think it's such a nice project for people to learn and get familiar with this without, should we say, too much risk of expensive components getting blown up in the process. So anyway, a little bit of a slow process of just putting all these screws in together, but you get the idea. And so here we are, just putting the base on. And as you see, these are the countersunk screws. So either using a countersink drill bit, or if you have a hand reaming countersink tool, which sounds very fancy, but are not especially expensive and are certainly invaluable in any sort of machine shop or workshop situation, just for taking off burrs and things on holes. So good little investment tool there. But either way, this should all go back together, and as you see, that is it, ready to install the Canary. Okay, so I hope you forgive a little bit of editing here. This is, as it were, here's one I made earlier, as I forgot to record the time-lapse for the assembly of the blue Budgie Canary. So this is actually an earlier prototype that I was just time-lapsing as well. So as you can see, you essentially lay all the pieces out on the table and then just super glue in the beak, the breast, the tail, and painstakingly the eyes, which are a little bit fizzly to get in place, and also the wing struts, which are the sort of little wing pins that hold it in place either side. So I'd say it's reasonably self-explanatory in that you can see where everything goes, but the key thing really is just to be checking that everything is sort of aligned and perpendicular, so that when you're gluing things, that the tail is allowed to sort of set square to the body. And indeed, when you're assembling things like the eye in place, I really recommend using things like cocktail sticks, and you can see me using the calipers here just to check that the wing pins are protruding. Mine happen to be 5mm either side, yours will be something pretty close. And what that does is it just means by the time you go to glue them in place and then use the small drill bit as shown here, little pin vise, cleaning out any sort of swarf or tightness in it, it allows you to insert the wire cleanly, and so that it flows really, really smoothly. And you can see me jiggling it about there just to make sure that it's really a very smooth and frictionless hinge. Not that the force of the servos aren't adequate to animate this little thing, but what you don't want is it being sticky and that the wing gets pushed up, and then because it's not actually very heavy, it fails to flop down. So hope that basically by doing a little bit of preparation, it'll mean you'll have a long functioning automata Canary, or indeed Budgie, depending on whether you went for the blue or the yellow option. So here we are, just showing how you pin the feet in as well. And again, this little technique of just using the wire and the super glue to lock everything together. Truth be told, I think when I'm looking at the feet here, again, because it was an earlier version, it was just like, as it were, 1 foot And the recent CAD model actually has 2 feet, so it's a bit of a nicer thing, and it looks a little bit more authentic, as if it truly is perching on the little crossbar. But essentially the principles are the same. So forgive my recording mistakes there. And so there we have it. It's starting to take shape, look a little bit more like the real thing. And again, a small subtlety is you'll probably see me soon begin to incorporate the magnets. Now initially I was putting in 4mm diameter by I think 4mm deep magnets, and in the end I realised that I didn't actually need a magnet quite that chunky and indeed that powerful, so ignore the fact that I'm drilling the holes out completely. Basically don't do that step at all, and simply place in the 4mm diameter magnets, which are actually now only, I believe, 1 or 2 millimeters deep. But essentially the operation is the same. The little struts, the arms that move it, go under the wing and in through the base, and the improved design that you'll be working with is nice because essentially it centers it over the magnet, so it all fits into place. So there we go. Now that you've got that, and you put the little motif of the cage into place and the bird, check it's all fitting, screw it in. And that edit was because I accidentally put it in backwards the first time. So easily done when trying to juggle all these things and filming. But again, this is the nice reason I don't use glue. Mistakes happen. So there we have it. The Canary is installed, and then this is a good moment to then worry about all the gears, putting in all the calibration discs, all that sort of stuff. So if you've ever made any sort of little automata as a kid at school, the principles are pretty much the same, that you've got a rotating shaft, and you've got either cams, or in this case it's a sort of pseudo cam, in that it's a linkage that is actually screwed into place. So it's not dependent on gravity, but essentially this means that as you put the bars in, as we are doing now, and then I was just putting everything back into place, and then I'm just tightening the screws so that the frame is square. And it's worth doing in that sequence in case the offset of the bird is a little bit different. But either way, and I realise what I'm doing here, which is a little bit slow, is I'm basically just filing out the center of the discs with a square file, and that's by design. That last thing you want to do is print something that is too big and it's sloppy, so it's better to print it a little bit on the tight fitting side and then file it and sand it down to fit. So nothing too strenuous that a good £10, $10 collection of mini files won't solve, or indeed if you haven't got that, get a toothpick and stick a bit of sanding paper to it, and then you can file away on the inside, and that'll also get the job done. So essentially it's a little bit hard to film this, but essentially what I'm doing is basically just aligning those arms on the wheels, screwing them into place, as you can see just there, and basically wiggling them back and forth so that the arm is straight in relation to the Canary body, and that the pins sit nicely under the wings, close as possible to the magnets. And then that means fold the magnets down over the top, and it's all looking good. So all I'm doing now is that I've, again, as always you'd imagine, I keep the wires a little bit long and then go in and trim back subsequent little tiny increments so that the fit is just right, and you can see that the wings are sitting in a nice position. So again, this is just a little bit fiddly. I suspect that if I did say that it's 15mm, the truth of the matter is, with variation from one printer to another and how you've assembled it, it will vary from person to person, but somewhere in that ballpark. So start off with maybe 20mm protruding and clip it back to what works for you. But essentially getting this bit right is probably the most, should we say, advanced part of the project, as it really is just the classic engineering thing of just getting everything to be just so, and so it does require a little bit of fussing to get right. So if you are inclined, or you do find the edges a little bit sharp, left by the clippers, you can of course just file them off. But other than that, there you are. It's ready to go. This is the Good Air Canary, an IoT device that lets you know the air quality around you.
Yawn. Cheep, cheep. It's a bit stuffy in here. Would someone open a window, please? Oh, blimey. Open a window or I'm gonna pass out.
Hopefully at this point you'd open a window for the benefit of you and the canary.
Phew. That's better.
But if you don't...
Oh, blimey. Open a window or I'm gonna pass out.
If you let CO2 levels reach 4,000 parts per million...
Spark.
You most certainly have an ex-canary. It is deceased, and you will need to reset it. And of course, remember to open a window this time. The Good Air Canary is an incredibly versatile Internet of Things device. You can connect it to all sorts of sensors, for example the ones shown here, or any number of APIs of your choosing. So download the open source files and make one today.